node, branch, loop, and mesh. So node, branch, loop, and mesh. So when we're talking about node, we mean a junction where two or more elements connect is called a node. So where a junction whereby this is not what you know as a junction, where two or more elements connect together. So when we're talking about elements, it can be a component or it can also be sources, voltage source or current source. So that is what we mean by what a node. So, and at least of what of two elements must be in that junction. That's what we refer to as node. So this is an example of node, and this one is another version of this. It's a distribution of a node. So a distribution node might be all spread out like this. So with lot of segments, elbows, and dots. So what does it mean? So you don't need to get confused with this one. So it is all just a single node. So connecting schematic elements with perfect conductors means the voltage everywhere on a distributed node is the same. So the voltage, and just like what we explained the other time, it doesn't matter if it is distributed or they are meeting at the same point. The voltage is always the same in them. So that is what we know and understand by a node. A node is a junction where two or more elements, a minimum of two elements, must meet at a point to form a node. So we can take a simple example on that one. So let's quickly look at this figure here. So how many nodes are in this schematic here? So this is a simple circuit, or you call it schematic, a circuit drawing. So we are looking for the numbers of nodes that we can find in this simple schematic. Of course, we define a node as a junction where two or more elements meet. So if you look at this place, we can call this place a junction. So though thank God we've been doing it based on steps. So we already know what dot and line means. So that's the best way to understand this. So we know there are some that are visible and the one that are not visible. So this, if you agree with me, this is a junction because it connects this element to this element. So I can call this one. So, and this, if you agree with me at the same time, this another adjunction, which means it connects this one and this one together, which is you can call two. So if you agree with me at the same time, I can call this one is a junction, which connect this one and this one together, which is also three. So this is also another one here, four. This for junction, which connect this side and this side together, which is four. And since we have already represented all this one with a junction, look at this one as well and this one. They connect this side. This is a single phase. They connect this side and this side together with each other. This uh this is a component. This is another component here. So this is a component here, this is a component here. According to dimension, a junction joins two or more. So this, from here to this place, you can call it another junction altogether. So making five junctions here. So the number of node in this simple schematic is five. So we have five nodes. So five nodes nodes are present in this case. So that is that for that. Now the next thing we're going to move to now is what we know as branch. So this is it. So when we're talking of branch, we mean a branch is a connection between nodes. So a branch means what? Connection between nodes. So when we're talking of branch, a branch contains an element. So it can be resistor or capacitor or any source. So the number of branches in a circuit is the same as the number of elements we have in a circuit. So these are the elements we have in the circuit. So the simplest approach to this is to recognize the number of branches we have in the circuit. It's just the number of elements we have. So which means whenever a current is flowing through any source, whenever a current is flowing through any source, so any point whereby the current can pass through and that will consume the energy is part of the branch. Let's say, for example, whenever this a component, so if current pass through this one, there is either a voltage drop or a voltage rise. So definitely this is what is a branch. So likewise the source as well is also a branch. Now if you look at this all together now, we will see that we have some number of branch here. So this one is first branch we have, which is the source. So this is the second branch, and this is the third branch, this is the fourth branch, this is the fifth branch, and this is the sixth branch. So altogether we have what? We have six branches in this circuit. So another thing we're going to be looking at is a loop. So when we're talking about a loop is any closed path going through circuit elements, or you can say um, a loop is a complete current path where current flows back to the start. So to achieve this, we have to select any node. So from the circuit, like the one we have, we have to select any node uh, as a starting point and draw a path. So through element or any nodes until the path comes back to the starting point or where it started. So that is how to form our loop. So and the rules is simple. We have to make sure that there's the loop can pass through a node just one time. So but it doesn't matter if a loop overlap of each other. So which means it doesn't matter if a particular loop contains another loop. So like what we have in our circuit here. So how can we determine the number of loop we have in this circuit here? So we can have this as our loop. Excuse me. So we can have this as our loop. Um, from the what we have here, we can take this one as a loop one. So that is the first one we have here. So and the next thing we have, this is another loop. This is another loop two, and this is another loop three. So call this one one, two, three. So and we can say this one is a loop as well. This is a loop. This is a loop. So and this is another loop as well. So making five, if I'm not mistaken, like that. So making five. So we have one, two, three. So the one that join this one together, the one that join this one, they are making five. So and this one as well, the one that contain everything can also be loop. So excuse me, is another loop altogether. So that is the loop we have in our circuit here. So that is the number of loop. Look, so we look at everything now. We notice that the number of loop we have in this circuit are six. We have six loops in our circuit here. So and the last under this is a mesh. A mesh. So what do we know as a mesh? So when I'm talking of mesh, we mean uh, a mesh is a loop that has no other loops inside it. So I think this one is very simple. We can actually guess our answer in this case from what we have here. So and we can easily differentiate between a loop and a mesh. So when we're talking of mesh, a mesh is an example of a loop which has no um, uh, uh, other loop inside them. So which means a mesh is always a loop, but a loop is not necessarily a mesh. So we can say a mesh can be analogized as a window pane. So it's like a window. So now from what we have here, we can easily assign this is first window we have here. This is our first mesh one. This is another window two, and this is the last window which is 3. That is what? That is uh that's the number of meshes we have here. We have three meshes. Three meshes. So that is all about that. So, and lastly, before we go, let's quickly take a look at this question, this problem here. List nodes, branches, meshes, and loops in the figure below. So this is the simple figure we have below. We want to list the number of nodes here, and I think we can get that. We can make it easily from what we have explained. We said a node is a junction where two or more elements meet. So that is what we are going to be looking at here. So when we're talking about two junction where two or more elements means we have what our A here. We can take our A here as one. So this one to connect this side to this side, and B here as well is a junction as well. It forms a junction here, so it's another junction too. So we have uh, um, we have we have C. This is a junction as well. Sorry, it is very easy. Let's take it from the junction so that we don't get confused. This is a junction, so which we can say it connects these sides and this side together, and we can say this place is a junction as well. We can say it connects this side and this side together. We can call this place a junction as well, which connect this side and this side together. And if you don't, if you will agree with me, this is place is also a junction as well. So which is our point B, which connects this two side and this side together. So it connects this side, point A and point D together, while our point A connects this side and this side together. Point C connects these sides and this side, or any of these sides together, because it's more than two already, connects these three sides together. So where our point D connect this side and this side together. So that's it. So which means all our nodes here, according to what we have here now, the first question is we are looking for nodes. So number one, our A now, the number of nodes we have in this question are simply um, the the point B, the point C, and the point D. Those are the nodes we have in this question. So the next thing is we are looking for the numbers of branches. We have been told that our branches are simply can be simply recognized by the numbers of uh, component we have in a circuit. So which means if we have something like this, we have some components that are placed in between. So it is very easy to identify, which means if we have uh, a line here, definitely there are some components that are placed between them. So our AB can be a branch, our BD is a branch, our BC, our CB, our BC is a branch, our CD is also a branch, like as our AD. So when I'm talking about that, is very simple. So the branches we have. So we have our what? We have our AB in this case. We have our BD. So BD is a branch as well. We have our BC is a branch, and we have our CD. Yeah, C from CD is a branch, and the last but not the least, we also have AD. From here to this is also a branch. It's a branch. I think that is well taken care of. So the next one we are going to be looking at is we have to look for the number of a mesh. So I think this one is very simple. So mesh is a loop that has no other loop under it that will contain no other loop. So this we have just three mesh. In this case, we have this is the first, second, and third. So I think that is very simple. So our mesh is just three. So our mesh is just one, two, and 3. So the D part, which is the last part where we are going to stop, we are looking for loop. So this is where we are going to think a little bit deeper. So when we're talking of loop, we said loop can contain single element. So and loop can also overlap loop. So if you look at this now, we have a lot of things to consider here. So we are going to consider the junction and the windows. We are going to consider the nodes and the windows. So we have 1, 2, 3 already starting. So 1, 2, 3 is starting already. We have one. So we are talking of the loops. Sorry, loops. So we have 1, 2, 3, both are certain. So now we're going to consider the junction. So the junction that are here, we are going to look at the junction. All the junction can also be considered as what? As a what do you call this? The junctions and the numbers of elements we have in each can also be considered as what? As loop as well. So in this case, we have our A. So we have our A. So we have our B, if I'm not mistaken. Yes, we have A here. There is element here. We have B, so we have C as well. There's a component here. We have C, we have D as well. So I think that is well taken care of. So that is, yes, we can see from that angle. So you can see from that angle. So if we are going to draw it, we are going to have if we are going to draw it. So what this one means? So excuse me, I'm going to put hyphen in front of them because they are together. So okay, I think this one we see ends at A. So we're going to have let me use black pen, my black pen to do this. We are starting from A, B, uh so what else we have? A B, A B, excuse me. This is supposed to be B first, A supposed to be D first before C, and here comes to be the last. So we have our A B D C comes to A, it's a loop. So remember we have this 1, 2, 3, these are three examples. A B D and C A is a loop. And the last but not the least, we can also have our uh, we can also have A, we have B, and we can also have D A, which is the largest, the one that cover everything. So we have the last one. Let's use our red pen to be from A, B, D, and to A. So that is the last part of it. So which means we have how many loops there? We have 1, 2, 3, 4, and 5. So in this case, we have five loops. We have 5 loops. So that is the end of our topic for this lesson, which is um, several important circuit terminologies. So to enjoy more of our videos, please do subscribe and um, share our videos. You can also give us thumbs up on this video to enjoy more of our video in the next subsequent topic. So thank you for watching. Till the next lesson. Bye bye.